Alright, and we're back. Coming at you live here. I'm going to do a quick homework review. This homework was due today. Hopefully the audio is coming in clear. That was all messed up last time, but there's no way to check it. So we're going for it. So I printed this out. Here we go, vector practice work. A cat has a mass of 3.5 kilograms and is dropped from 1.5 meters above a landing pillow. Oh, nice. If the air resistance causes a 25 Newton resistance force in the opposite direction to the cat's motion, what is the net force acting on the cat? Alright, so here, F net equals question mark. We got to find that. So there's two ways we could do it. We could either find the total force acting on it, because that's what net force means, or we could use F net equals MA. So we'll have to decide. But first, we will sketch a quick diagram. Here's a cat. It has two forces acting on it. It has, of course, the force of gravity, which is equal to mg, pulling it down. And it has the force of air resistance, Fa, and that's equal to 25 newtons, pulling it up. So here we got to find the net force. So, does it say anything about its acceleration? Reading the question again, mass, height. It doesn't. I know the acceleration due to gravity is 9.81, but there's air resistance here, so we don't know the actual acceleration. So we can't use this one. So instead we're going to just find the total force. So I have 25 up, and I need to solve for how many I have going down. So that means I need to solve this equation. Fg equals mg, which remember is just your weight. So Fg equals the mass of the cat, 3.5 kilograms, multiplied by negative 9.81 meters per second squared. Get my calculator out. 3.5 times negative 9.81, and we get force of gravity is equal to negative 34.3 newtons. So this is equal to negative 34. I'll just round it off there. So now I just need to find my net force. So I need to add up my forces here. My F net is equal to my total force, which is my air resistance plus my force of gravity. So I substitute those in. My F net equals 25 newtons plus negative 34 newtons. So my F net is, yeah, let's use the calculator. 25 plus, oops, that's a negative sign, plus negative 34. There we go, negative 9 newtons. Question 2, poorly written. Don't even worry about it. It's out of here. Question 3. A 5 kilogram owl is at equilibrium sitting on a... Oh, love it, vocab word. Equilibrium, what does that mean? Jackie, do you remember?
Equal.
Yes, it means what's equal though?
Both sides.
Yeah, both forces acting on all sides are equal, so the net force is equal to 0 newtons. So what's the net force? It's just 0 newtons. Here, here's my owl on a branch, so you have Fg pulling it down. We have the force of the branch, and those two are equal to each other, whatever the value is. Alright, so those are the vector ones on the front. Now onto the one on the back. This is just like your lab, just like the one you're going to probably see on your quiz on Friday. Did I tell you about that yet? Spoiler alert! So here we go. We got to pick, and the whole rule of this game is to find the, or rather only get everything in X and Y. That's step 1. And then step 2, make a right triangle and solve. Okay. So I look here. I've got 30 Newton vector and 36 Newton vectors. Clearly, these things do not just magically make a right triangle like this. That doesn't make any sense. Can't do that. So I need to take this one, and I need to split just this one up into its y component and into its x component, ax. So to do that, I'm really just taking my 30 Newton vector, and I'm breaking that one, 48 degrees. The 36 Newton vector is okay, because it's only going in the x direction along the x-axis. So here we go. I need to find ax, and I need to find AY of 30 newtons. So AY equals A sine of theta. AY equals 30 newtons sine of 48 degrees. Make sure you're in degree mode. I am. Oops. So we just do 30 sine 48. And AY is equal to 22.3 newtons. And then I do the same thing with AX. A equals A, except it's cosine of theta now. So AX is equal to 30 newtons cosine of 48 degrees. AX, check it out. Cosine of 48, and I get 20.1 newtons. Alright, this is good. Now, I have something in the y direction, one thing in the x, another thing in the x. So everything's either x or y. I've done the first step. Now, next step, make a right triangle. So now let's see. I'll do AX first. So AX equals 20 to 0.1 newtons. And again, this means line it up tip to tail. So the next vector, I'll do another x1. So that's my original one from here. I didn't have to change that one. I just have originally 36 newtons. And then the last vector I have is AY. And that equals 22.3 newtons. So I could sketch my results in here, R. And I could solve for that because I made a right triangle. That's the whole point here. So we got a squared plus b squared equals, oh man, I'm off the page. I didn't realize. Jeez, what an error here. I'm sorry. What a blunder. So I lined up tip to tail. So the AX, well, is this vector because I was in the x direction. And I said, all right, what else is in the x direction? So I lined the next one up at 36 newtons. That one. And then AY is in the y direction. Good. And remember, when I do this, I've destroyed my 30 newton vector. It's not one vector, it's two vectors now. I've decomposed it. So I'm solving for R, the resultant there. So this equals c squared. So I have, we'll make A 22.3 newtons squared plus B, which is 36 plus 20.1. So 56.1 newtons squared equals c squared. So c equals, let's see, we do 22.3 squared plus 56.1 squared. And then we take the square root of our answer. And we get c is equal to 60.4 newtons. Very good. And then the last thing they ask is to find your angle, how far above the horizontal axis. So we're going to use SOHCAHTOA. Any of them work because we know all three sides. I'll just use sine. So sine of theta equals my opposite over hypotenuse. So sine of theta equals my opposite, just 22.3 newtons, divided by my hypotenuse, which is r, which is 60.4 newtons. So I'll move my work up here. So to solve for theta, we got to get sine to the other side. So that means we do the inverse sine, 22.3 divided by 60.4. So plug this all right into your calculator just like that. So clear this. So second sine to get that -1, that's crucial, of 22.3 divided by 60.4. And hit enter, I get 21.7 degrees. So there you go. We've done tons of these now. There it all is. I'll zoom out maybe. You can kind of see it all here. Yeah, so that's probably going to be on your quiz on Friday. Thanks for watching. Have a great day.